Hey Dinesh, morning. How
Good morning, sir.
are you, Dinesh?
I'm good, sir. How are you?
Good, good. I'm also good.
That's good. Thank you.
All right. So, hi, battalion. Good morning. Meanwhile, other people are joining. Let me set up the labs for today class. We'll have some IP assignment. There as well. Okay. So, meanwhile, others are joining. Let me quickly build this lab. We have to do some testing, ping, trace like that. Some configuration. So, I'll put the host name as R1. Let me put the host name as a R2. This is going to be host name as a R3. R4. Host name as a R. Okay, this should be R7, not R4. Okay, this is going to be R4. This is going to be enable config T host name as a R5. This is going to be my host name as a R6. Okay, so we'll do the quickly IP assignment on the interfaces. The very first thing, I will configure 12 IP on this Ethernet 0 by 0. So interface Ethernet 0 by 0, IP address 12.0.0.0.1, 255, 255, 255.0, no shit. Show run interface Ethernet 0 by 0. This is the configuration. I will copy it. I'll go in the R2. This is the Ethernet 0 by 0 as well. So only what I'll change it. I'll make as a true, no shut. Let me increase the font size as well. And we are good. Let me try to ping 12.0.0.1 should be reachable. This is the very first thing. Yeah, it's reachable. Now I'll go on the interface Ethernet 0 by 1 and I will configure IP address 23.0.0.0.2. So whatever the router name, I will configure as a IP address. And then 255, 255. And then 255.0, no shit. This is done. Now I'll go on this interface 0 by 2. Okay, one more thing. I'll enable the 𝗵𝗴𝗃, right? 𝗵𝗴𝗃, I'll give that process ID 10, area 0. I'll configure the OSPF just for the testing. So I will go on the Ethernet 0 by 2. We'll discuss OSPF later, but I'm just doing for the lab purpose. So, or I can do in one go in global configuration, router OSPF 000, every network is going to be advertised. So 0 by 2 is 27. So let me go here and 0 by 2 is going to be 27. Okay, no shut. And here I will configure router OSPF 10. Instead of the interface, per interface, I will configure 000 and area 0. So every network is going to part of the OSPF. That's all. Simple. So You can see show IP interface brief and show run section OSPF. This is the final OSPF configuration. On interface, you can ignore that, no problem. So I given that this configuration. Now go to R3. R3, I have the interface 0 by 1. Okay, Ethernet 0 by 1. So Ethernet 0 by 1. IP address 23.0.03, 255, 255, 255.0, no shut. Okay. One more interface I have 0 by 2. So 0 by 2 should be there. And this time IP should be 34. So I will give 34, no shut. Okay, that is fine also. And I will configure again OSPF here in global. So router OSPF 10, network 0.0.0.0, area 0. That's all. And you'll see eventually we'll have the OSPF neighborship after some time. Okay, so minimal OSPF is getting built. Let me go on the R7 and let me configure these two interface as well. So on R7 Ethernet 0 by 2, I'll configure 27. IP address 27.0.0.0. I will leave the IP as 7 here. Okay. And, okay. So 255, 255, 255.0. No shut. And one more interface I will configure. That is a 0 by 0. So I will go simply 0 by 0. And this time IP is going to be 47. So I will configure here 47. And I'll give the 7 here. And I'll configure no shut. I'll configure router OSPF 10 network 0.0.0.0.0.0.0.0 area is going to be 0 and done. Let me see this OSPF is built or not. Okay, so see there is a OSPF neighborship up. So we are good till here. One OSPF neighborship is up with this router. Okay, let me configure OSPF for R1 as well. I want to build OSPF for R1 as well. So I will go here router OSPF 10 network. I will give that 0.0.0 and area 0. I'm just enabling for the all network OSPF neighborship. So in R2, probably we have the 2 OSPF neighborship. So not 2, it should be 3 OSPF neighborship. And now you have a 3. And see, they have the OSPF 0 by 0, 0 by 1, 0 by 2. So everything is good till here. So we are good. Now let me go on the R4. And R4, I will go on the interface. There is two interface 0 by 2 and 0 by 0. So I'll go interface 0 by 0 and IP address 47.0.0.0.4 255 255 255.0 no shut. Now I'll configure one more interface 0 by 2 0 by 2 and here IP address is going to be my 34. So 34.0.0.4 255 255.0 no shut. And again, router OSPF 10 network is going to be 0.0.0.0.0.0.0 and area 0. And right. So you'll see eventually it is also going to build a OSPF neighborship. Now I'll go in the R5 and R6. So again in R5, I'll go on the interface. There is two interface 0 by 3 and 0 by 2. Okay, one more interface need to configure the R4. I missed that. So you can see OSPF neighborship also up here. So here is going to be 0 by 3. Internet 0 by 3 and IP address is going to be 45. So I will use 45.0.0.0.4 55.55.55.0 no shut, right? And now we are good. And let me go here again, interface already on the interface, and this is going to be 0 by 3. Ethernet 0 by 3 IP address 45.0.0.0.5 255.255.0 no shut. and one more 56 0/0. So it is going to be 0/0. IP address 56 0.05 255 255.0. No shit. Okay, again I'll go and configure router OSPF 10 network. I will give that 0.0.0. Area is going to be 0. No shit. Okay, so you're going to see OSPF is also built here, right? The last but not least, I will configure loopback 6 and also configure the IP address. So interface Ethernet 0/0 and IP address is going to be 56.6 to 55 to 55 to 55.0. No shut. One interface loopback 6 IP address 6.6.6 to 55 to 55 to 55 to 55 to 55. And then I'll configure router OSPF 10 and network is going to be 0.0.0.0 0.0.0.0 and area is going to be 0 and this is done. Show IP OSPF neighbor. You'll see eventually it's going to be make OSPF neighbor SIP as well. Yeah, now it's fine. So show IP OSPF neighbor. We are good. So probably on the R1, you're going to get the route of the 666. Still not have the route. Let's wait for a while. It is going to be there. Yeah, you able to see this OSPF route. And if you ping this one, it is going to ping as well. If you trace that, it is going to trace as well. So we will just make the reachability and we'll see this trace is going to be through from the my source to destination. So the topic we are going to start today is a network assurance. Okay, infrastructure we park this layer 3 routing. We'll discuss later. Don't worry about that. I will complete. But we are talking about the network assurance. Network assurance is all about how you get going to diagnose the debugs. What is a conditional debugs, right? And what is a trace route? What is a ping? And what is the SNMP and what is a syslog? That we have to discuss. So we'll discuss first ping and trace. That is the easiest topic. And then we'll discuss about the conditional debugs as well. How the conditional debug is going to be configured. So if I'm going to discuss about the ping, what is a ping? So ping is nothing. Ping is the one of the critical tool for the troubleshooting. Means anything you want to make sure you have a reachability or not. Means from source to destination, any applications, any server. So it is going to always help to check based on the echo reply, echo request and echo reply. Whenever you're doing the ping, you're going to get always echo reply and echo request. Let me suppose that if I'm going and just want to capture the packet. Okay. It's not okay. It's enabled Ethernet 0/0. So if I want to capture the packet, so whenever I'm going to initiate the ping, so it will going to send the echo request and echo reply. And based on that, it is going to monitor all kind of the your network activity and it is going to give the response whether you're able to reach or not. So basically, it's going to gather the fact we have a reachability or not. You can always ping from the CLI. You can see always going to ping. And if there is any packet loss, let's suppose you're pinging by default, it's going to send the 5 packets. And you're saying like any kind of the packet loss is happening. So you're not going to get 100% success rate. And also you're going to see if you're doing the ping, how much average loss means latency you're getting that. So by default, in our case, because we are in the lab, so you can see when I ping, it's a average is like minimum is 1, average is 2, and maximum is 3. Let 3 milliseconds. Still latency is there. So this is the like ping. Ping is like always one of the utility, and it is going to be always help to check if there is no reachability. Let's suppose you're trying to ping some destinations, and that destination is not available in network. Let's suppose 7.7.7. This is not available, so it's going to show you 100% packet loss. It is not available in the network. Means this is not available. And you want to do the extended ping. There is one more method. You want to do the extended ping, so you can use some additional informations as well. So normal ping always going to be ping, but there is a ping, and then you want to extended ping. So extended ping, let's suppose I just want to use a 6.6.6. And then after you can see you have the options. You want to set the how much packet size you want to ping. Let's suppose 1400. So you give the 1400. What source you want to ping? From which source you want to ping? Let's suppose I want to take a source as a loopback one. Let me create one of the loopback one. By default, if I'm not making any source, then it is going to take a your this exit interface as a source. By default, anytime if you're going to do the ping, if you're not making the source, it is going to take as a exit interface as a source. Whatever the exit interface you have, it is going to take a source. So you can see here, this is a multicast, but I will show you. Wait for a while. So let's suppose I'm going to create one of the loopback in the R1. Then I will try this ping. So interface loopback 1, IP address 1.1.1, 255, 255, 255, 255. So the moment you're doing that, this interface is going to be available, and this must be also reachability layer because OSPF already defining the default route. So now if you're trying to ping, right? Ping 6.6.6 with source, sorry, ping 6.6.6. If you're not putting source, it is going to take by default exit interface as a source. This interface as a source by default. But if you're putting source, then it is going to take a loop back. And what size you want to give? Let's suppose 1400. And what else you want to get? How many repeat time you want to get? Repeat time you want to get like suppose 100. Then what is my DF bit? What is a DF bit? Defragmented bit means how much packet you want to set as a defragmented. So let's suppose I want to give like a this particular packet is going to be defragmented. Means it's not going to fragment it. Means any device in between, if doing the fragmentations, my ping is not going to be successful. So my packet is going to be only 1400 side without any fragmentations. So if you go and search what is DF bit in the ping, so you're going to get at. So it is going to tell you in the context of the ping command, DF bit do not fragment bit. Means a flag in IP header instruct every router along with the path, not fragment the packet. Means whatever the size you're sending, that is going to remain the same. So this is the DF bit. If you're not putting a DF bit, then what is going to happen? Might be in between of any host, any path, it is going to fragment your packet. And that is going to be, uh, just complete your ping rate space. If let's suppose some packet, some router side having the MTU size, MSS side is 1300, but you're sending the 1400. So they will fragment your packet and allow that communication. But if you want, no, I want to make sure my packet should be 1400 throughout the path. Then you have to set the DF bit. And if any router is doing a fragmentation, in that case, ping is not going to work for you. So that is a DF bit. I think it's clear. Dinesh, Badalian, Sridhar, these three things, all commands, you understand?
Yes, sir.
Okay, now what else? So DF bit, if you're setting, we have the data pattern. So if you want to give the data, so it is going to see like hexadecimal data pattern. It's not needed, but if you want to see the data pattern in hexa pattern, it is going to give the data pattern as well. And let me put a data pattern as well. And you have the, if you put a data pattern, it's going to be hexa. You have to give that hexa format. So I need to check the hexa format exact what all value I need to put, but timeout. Timeout, you just have to give like how many seconds you need. If the ping is a lot of delay, so you can give the timeout 30 seconds, 50 seconds. So it's also not needed. But sometimes you need toss bit, means you want to give the toss bit like EF. If you go for the QS calculator, if you go for the QS calculator, you're having the different toss bit for the different services. Let me show you. See, so DSP value is there. You can see this is the toss bit. Like it's a toss is basically going to be your type of services. So type of services, let's suppose you want to use the video services, then you have to set the toss bit as a this value like 136. If you're using the voice 184. So if you want to give that the QS check also, you can give that also. There's no problem. But you don't want to give the toss bit, you can just leave it. And validate reply, that is going to be, validate the reply from the all data. But generally we use this size, and you can see if I try to ping, it's pinging. 100% is a pinging. So most of the time you're going to get that kind of the ping. One more thing, ping, if you're just doing this way, you have to give the extended ping. Another way also available. Ping and then IP protocol number. If any protocol number, like you have the GRE, ESP protocol number, AH protocol number for the IPsec, like 50, 51. So every protocol have the protocol numbers. So if you want to use the protocol number, you can just ping it. If you don't have the protocol number, just give the target IP address. So 6.6. Now repeat count. Let's suppose I want to give the 50. Datagram size, let's suppose 1350. This is the empty size. Time in second, 2 second listen. Don't give them more than that. Okay. Exit. Extended command. Yes, I want here. Extended command. Yes, you need to put yes. Source interface 1.1.1. Right. Type of services. See, type of services. What type of services you want to give that? So then you have to give the value from here if you want to use a type of services. So you can give this type of services value from here. So I don't want to give. And then you want to see the DF bit set. So if you want to put yes, you can put it. Validate reply no, data pattern no, right? And these are the like verbose, loose, strict, record. Means it is going to be, if you just understand. Let me explain this. If you go here. So how long each reply is waited for? So you can give the timeout. 2 seconds here is a repeat count. How many repeat run? You can give it. Now here say loose, strict, record, timestamps, and data pattern. The data pattern used to ping packet default is that this hexa format they are going to give it. But if you want to give the any other data pattern, you can give that. You need to calculate. Type of services I explained that. Source interface, source address or interface I explained. Now we have this loose, strict, record, timestamp, and the verbose. This also you should know about it. Loose is specify the hope that ping packet should traverse. Means you can give the intermediate hope where my packet need to be travel. So that is the loose, a specific hope that ping packet should traverse. So if you go here and use the loose, right? So you have to give the source route, right? I don't want to give, but you have to give, let's suppose, source route. And then you can see there is the means you just I've given the random IP means where the traffic should go, but I want to give any, let's suppose 23. Okay, let me first complete, then I will give that. Now the second is strict. Same as a loose, with the exception the packet can only traverse the specific hope. You can see this is also, but in that case, it is also going to travel in the backup hope if it is available. If this is not available in loose, in case this hope is not available, your packet might be going to travel in the different hope. But if you are going this strict, then your packet is going to only travel with the specific hope you want to mention in the your ping. Record is the basically display IP address of the first 9 hopes. And that is the ping packet traverse. Means only first 9 hope you want to see that, then only you record that. Timestamp display the round trip type destination each ping. Means you want to see the timestamp, you can just give that. Verbose means default option that automatically select with the any of the all other options. Verbose default option that automatically select with any and all other options. Means whatever that. So you can give the verbose is the best example. So let me go here. Let me see that. So you can see this is the they're gathering the all kind of the informations. It will take a time, but I run this command, so it is taking time and it is going to complete that all reply. So it will keep trying to check, keep trying to check. I need to stop. It will take time. Hold on, guys. So ping is a very huge utility, right? Very useful utility, and you're going to find always these all things. But most important, you should know extended ping. And if you want to know this loose, strict, timestamp, and verbose, then it is going to be good. And you can just define the source IP address, destination, and type of services. See, 184 data pattern. Time default is verbose. So if you are want to not use these all, verbose is going to give all the timestamp. It is going to record the IP address, And 𝗏 is also given the, like, if you go on the Google also and just search it. Okay. 𝗏, you specify the list, must widget IP address, hope. Simple, strict. You specify the exec the packet must take. It will not encounter to any other things. Record is going to record the 9 hops. Timestamp is going to time. Verbose is not a packet header option itself, but display settings it automatically enable when you select the other option in storing. So this verbose is going to by default enable when you're going to enable the any of the settings. So by default it is going to be there. So log is influence the path. Strict is exact path you want to follow. So it is going to influence the path, which path I want to send the traffic. Means you have the multiple path and you want to influence, I want to send the traffic with the some certain path. You just have to use the lose command. Record is going to record the any kind of things. So let me check it if it is ready now. So let me try to um, trace. I will use the 6.6.6 source 1.1.1 and ping I'm not using. I'm using the trace this time. Okay, so I want to use the lose. So I want to give like 2300, 2300. The IP should be 3 here. So it's a verbose by default selected. You can see this is a verbose by default selected. Lose IP is verbose selected. So you see now I'm tracing the route. And let's see what is happening. See, very first stop. Now the second hop. This is the very first stop. This is the first stop and all information they are showing that. Now this is the second hop. And what is the address? This one, 23003. Now it's a 34.3. Third hop, 33.4. Now its packet reach here. Now it will reach to 45 and then 46. So it's sick time. Now it's 45.5. So you guys can try to play on this. It's very fun, okay? And see what is the behavior. You can read that everything. But it's not like a normal ping. You have to get a lot of output in the verbose, loge, whatever you want to do that. And we are the last hop, 56. So finally, our trace is completed. Now, if you're going to take a trace again, last time, last thing I'm just giving that source 1.1.1. Yes, leave it default. Sorry. Sorry, guys. So I want to give this verbose. See, only verbose, not loose verbose. So if I use the loose, it will take the verbose by default. See here, when I use the verbose, it says the become the LV. If you're doing S strict, it will become L. So verbose is by default is going to be always included. But if you're using the only verbose, just click OK, and it is going to give the normal trace. So our normal trace is always going to verbose. But when you're going to put the specific, loose, strict, record, timestamp, then it will become the extended verbose. Clear? Ping is clear, guys? Do you guys know these all things in past? Have you learned these things in past ever or first time learning? So in book, it is all available. You can just read about it. And I hope you are good with the ping. This all extended ping you can see. This is the extra pattern. You can set it and then we can do that. See, they are doing the extended ping as well. And here the timestamp they are selected as a ping. And then you're going to get all time as well. Like PST time, they are going to give that. Now we have to talk about the trace route. What is my trace route? The trace route is the feature, means when you are going to do a trace route, simple trace route 6.6.6. So how trace route is going to work? Trace route is a feature whenever you're going to send the trace route, it send with the TTL value 1. But when it is going to reply from your next hop router, it will again increment the TTL value and send to with the again the packet. And if they're going to reply, then it will again increment, and if destination is not final, okay, but this router know, yes, I know that particular destinations, so it is going to simply send the reply. So in that case again it is going to increment that one more detail and it's keep sending until the packet is going to reach the destination. In case your packet is going to be not reach destination for some reason, so it is going to be give the timeout, means destination unreachable. But in case if your hopes are getting reply, means they are giving a reply one by one. So it will keep sending the TTL value after doing the incremental TTL value again and again. And it will reach to destination. So this is the trace route. Trace route is another common troubleshooting tool. Trace route often used to troubleshoot when trying to determine where the traffic is failing, as well what path traffic take through your network. Means if I'm reaching from this source to this destination, which path right now taking? This path or this path? How you come to know? So if you take a trace, you see the traffic is going from the 23.3 right now, right? 23, not 27. But in case this link is going to be down for some reason, let me suspend it. Now if you're going to take a trace again, sorry for so might be you see some hope are not showing. Why? Because they might be converging. So that's why not showing. But let me take one more time trace. You're going to see the secondary path for sure. The asterisk is showing some reason might be the path is not converged fully. So that's why not showing. But let me take trace one more time. See, so now it's going either. So trace is a utility. If I just again no shut this one as well. So trace is a utility which is going to be useful to understand which path traffic is going on, and is going to give that every path, even the loss latency. Means latency basically, not loss. If loss is going to happen, definitely you're going to get packet loss, but you're going to get latency, how traffic is going on, what is the latency on that particular path. So these all information is going to record as well. So this is a trace. You just go here and it is going to try. If there is trace is unreachable for some reason, let's suppose I'm putting a trace, this one. So it's maximum going to try for the 30 hop. So I'm putting a trace, right? So it will try to go up to 30 hop. If there is no reply up to 30 hops, by default, it will make as a unreachable. Okay. If the hopes are getting reply, it will keep increasing the TTL value step by step. So you can see if there is a hope which are not unreachable, host reachable or unreachable, then you're going to get that also option. And the same thing I explained, you can just give the probe source and all. So traceroute have a lot of option. TTL value, you can give that also. So traceroute with the port number, you can do that. Source interface, which source, how many probe you want to send, and what is the timeout. You can just define a traceroute also. And these are the again options. Protocol means what the protocol you want to use. Target IP, which target IP you want to trace. Numeric display, you have to see that. You can see that also. Time in second, probe count, how many want you. 3, 5, 10. What is your source address? TTL value. By default, it's going to be increase or decrease based on the your network behavior. Decrease is going to happen if it's going to exceed the TTL value. 30 is going to happen, then make the 0, and then packet is going to be drop. But increase in case everyone is going to reply. You can give the maximum number of before it 30, but you want to increase more than 30. So even it is going to more than 30 hops. Right now you can see it's reached till 9 hop. So by default 30 is the default TTL value when you're going to give that port number, you know that. And this is again verbose record time, first time, the same thing is going to be there. And you can give that, and here is your trace. In case of the timestamp, and then it's going to count your all timestamps for the all hopes where packet is going to be land. So now if you go and search how trace route work, so you're going to get the similar thing what I explained right now. So deliberately targeting the error message for the every router between your destination time to live. TTL1, where computer send the packet with the TTL1, first router hits your gateway and drop the packet because TTL expire. And it send back the ICMP time exceed message. Means your next neighbor router or neighbor gateway is going to say your TTL has been expired, so you are going to send the ICMP exceed message. Then your computer again increase the TTL value to, and your computer send another packet with TTL2, and it passes to first router definitely, and it will decrement the one, but at this time it will not send the time to exceed because one more TTL is available. So your packet is going to die at second router because second router will see TTL is 0, so I will send the again ICMP exceed message. Then it will send again 3, and then once the packet reaches to target or destination, send back the final response like ICMP reply. Means once your destination packet receive, then it will not send to ICMP exceed message. It will send the ICMP reply, or it's going to send, if there is IP no reachable, then it's going to say the port unreachable, right? So this is how you're going to work. And by default is 30. And you can see right now 22, and it is going to reach that. So I hope it's clear. Traceroute and ping, guys. Any doubt? Or we are good with traceroute and ping? Okay, now let me move the new topic.